Welcome to the 5th installment of Getting Started with LT-Spice. We are going to go over noise simulation. This simulation is a frequency domain noise analysis which includes shot, thermal, and flicker noise parameters. The result in units of volts per square root hertz is plotted to aid in circuit design analysis and your overall understanding. We're going to continue with the preamplifier circuit from the previous video. So to run a noise simulation, we'll go to Simulate, Edit Simulation command, Noise. Let's go ahead and delete these. Under noise, you'll see that type of sweep, number of points per decade, or number of points per octave, start frequency, stop frequency is just like the AC analysis. So if we go back over to noise, the difference is that you need an output reference and a specified input reference. The output reference is going to be the voltage seen on your output node. So you actually have to label that as V, open parentheses, out, close parentheses, or whatever this node happens to be labeled. Your input is just actually going to be your voltage source, which is VCC. I prefer decade. We'll do 100 points per decade. We'll do a starting frequency of 100, and we'll stop at, let's say, 20K, since that's the audio range and this is an audio application. Drop that down. Let's run it. So we'll probe the output, and here we can see that we're getting a noise of 4.8 microvolts per square root hertz. Which really isn't going to hurt anything. Now if we want to see, so since we're here, let's take a look at this. So if we click on a node, you can see down here at the bottom of the screen, it'll say this is node 3, DC operating point 2.5 volts. This simulation linearizes the circuit about the DC operating point. So you're not going to be able to probe and get voltages. It's only because it's only going to give you the operating point, which you remember from the first video doesn't have a waveform. But if we wanted to look at the noise contributed by different components in the circuit, specifically the one that's in this feedback here, let's click on it and see what happens. Okay, so we do have a noise component generated by this resistor. Now let's say we want to ignore that. Right-click the part, and in resistor you can add a flag called noiseless, and it's going to remove that noise component. And it really doesn't change the circuit all that much, but that's because it was, a couple nanovolts per square hertz. But that's how, if you wanted to run a noise simulation. So if you're doing anything with like audio or high precision op-amp design, you're going to want to run a noise simulation to see the behavior. And I have an example in the tutorial where that could be a potential problem.